Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today I am going to discuss with you about integral and differential form of Gauss's law. This topic is from chapter 3 of class 4th year. As we have discussed about Gauss's law in our last lecture, what is Gauss's law? The Gauss's law states that the electric flux passing through any closed surface is equal to 1 over epsilon naught time charge enclosed by that surface. For integral form of Gauss's law, the volume charge density is defined as the charge per unit volume is called volume charge density. It is represented by a letter rho, and mathematically it is expressed as rho is equal to dq over dv, or you can say that the volume charge density is equal to derivative of charge with respect to volume. The charge enclosed in the volume element, in the small volume element, is equal to dq into rho into dv. To calculate the total charge in the whole volume, you integrate both sides of this equation. The resultant equation will be q is equal to integral rho into dv. This is the total charge enclosed in the whole volume. The net flux through the entire surface is equal to phi is equal to closed surface integral of the dot product of electric field intensity and area element. Now putting both of these equations, total charge and the net flux, in the Gauss's law, the phi is equal to q over epsilon. Now putting this value of the phi and q from equation 1 and 2, the resultant expression will be closed integral of the dot product of electric field intensity and vector area is equal to 1 over epsilon naught time into volume integral of the volume charge density into dv. This is the integral form of the Gauss's law. Now the differential form of the Gauss's law. We derive differential form of Gauss's law by using its integral form. By applying divergence theorem on the left hand side, the expression will be changed into E dot closed integral E dot d is equal to integral into del dot E into dv. And by applying divergence theorem, the surface integral change into volume integral. Now both of these equations have the same left hand side. Now comparing both of these equations, the resultant expression will be like this: integral of the volume integral del dot E is equal to into dv is equal to 1 over epsilon naught time volume integral rho into dv. Now both of these equations have the similar derivative, that the dv. On taking both of these on the left hand side, the expression will be changed into the resultant expression del dot E is equal to rho over epsilon naught. This is the differential form of Gauss's law. You can say that the divergence of the electric field intensity is equal to volume charge density over epsilon naught time, or the permittivity of free space. The divergence of the electric field intensity is equal to volume charge density over permittivity of free space. This is the differential form of the Gauss's law. This from today. Thank you.